That's how things play out across grades. And there are documents of the Institute for Math and Education at the University of Arizona, where my fellow author and the overall mathematics lead, Bill McCallum, is progressions documents. Anybody read progressions documents or seen them? So great. All the hands are up. They're dense. They're sort of, dissertation-like. We've tried to edit them to make them more readable and less academic. Nevertheless, they're extremely valuable resource for just sort of hearing the story of, say, how does multiplication develop for grades 3 through 5? What is that story like? You can obviously cut and paste from the standards document and stare at the standards and try to get a sense of it, but it's also good to hear it in prose sometimes, and the progressions documents do that and are valuable. They also have in the margins sometimes just some nice little problems that make a point better than words can. For example, if you look at the one on K5 data work, which, as I've said, is very minimal and very tightly tied to the development of progressions in arithmetic, you'll see there's a table there that shows for each standard in the K5 data work what is the connection to make to the arithmetic work. So there's some goodies in there. Now, so as I say, I've talked about progressions across grades. Of course, we want kids to make connections at a single grade, right? Connect things together. That's the typical meaning of coherence. And what I wanted to say about this is that unlike, I think, previous standards, which were kind of like a bucket of ball bearings, right? That you just kind of put them together into something that kind of fall through your fingers. There are, in the Common Core, there are specific standards that are meant to make a connection inevitable. So for the most important connections, there are standards there that are trying to make them inevitable. So for example, here are 3 ideas in grade 3, 3 big ideas in grade 3. Multiplication and division, properties of operations, and area. Right? There's a standard about area, there's a standard about multiplication and division, there's a standard about properties of operations. But there are also specific standards that explicitly live in the connections between these things. So there is a standard 3MD 7C that is explicitly about linking properties of operations to area. There's a specific standard 3MD 7A is explicitly about linking area to multiplication and division. And this is really so that textbook companies, in their habit of just going standard by standard and spitting out lesson by lesson for them, we didn't assume they were suddenly beginning to become virtuous and mathematical and stop doing that. So we wanted even an automatic conversion of standards into textbooks, as too often happens, but at least hit these connections. High school coherence is very important too. There are a lot of topics in high school. We talked about the need to spend the majority of kids' time on the widely applicable prerequisites for the next phase of their education. There's still a lot of topics left. And coherence is a way of achieving focus. So there are 3 topics you can find in the high school standards. Equation of a circle, the distance formula, and trigonometric identity, sine squared plus cosine squared is 1. If those are 3 topics, then that takes, 3x amount of time. But in the teaching of them, they're really one topic, right? The Pythagorean theorem. For someone who kind of understands what's going on, this is all just a Pythagorean theorem. And so the more teaching can attain that ideal of, this is all this, then you get to save time as well as build understanding and more robust mastery of mathematics so that, somebody forgets their memorized formula of the equation of a circle, they can maybe put it back together. So focus and coherence, two big shifts and tall orders, and what they buy us is an opportunity to seek greater rigor. And again, stressing that's caring equally about conceptual understanding, procedural skill and fluency, and application. In the breakout, we'll look at some problems that, crudely speaking, fall into these 3 buckets. So the breakout will be a lot about rigor and what that feels like, what that looks like, what that means. We'll go through just a couple of problems here. Here's the conceptual understanding. Write 4 fractions that are all equal to 5. I gave this to some friends of mine, you know, there's everyday folks from Detroit and from. It exploded. 5's not a fraction. Can't do that. Here in place value, this is a problem that you can find on achievethecore.org organization's website. There's a place value worksheet. You'll notice these are all kind of worksheet-like. I think conceptual understanding in the classroom often is related to talking, making arguments, expressing mathematical arguments, critiquing mathematical arguments. But there's also a sense of it in which it's amenable to questions that are like, that reveal if someone gets it or not, and that lead to interesting conversations. So I don't think conceptual understanding always has to be kind of like extended essay. So 14 tens, you know, this is a fill in the blank. 14 tens is 10 tens plus blank tens. It equals blank 100 plus 4 tens equals blank 90 plus 300 plus 4 equals blank. There's a lot of scrambling going on here, involving the three, as it were, pillars of place value, the sizes of the base 10 units, the fungibility, recursive bundleability, and unbundleability of place value units, and positional notation. So those three things are all very alive in these kinds of activities, which you contrast if you go to the web and search. I need a worksheet on place value. I've been there. I mean, college costs a lot of money, but I'm happy to tell you there were times the night before I went and found something on the web. Well, what you find on the web doesn't often look like this kind of thoughtful exploration of the conceptual. You know, here is a death march through hundreds, tens, and ones. And kids are smart. They're going to see after, you know, God forbid, I hope there's no more than one of these worksheets, but partway through the first worksheet, they're going to figure out, okay, first number in the first blank, second blank, third blank. That's not the lesson we're teaching in place value. Conceptual understanding. There's times when it does have to do with reasoning. Am I putting this together? Can I articulate this? Amber didn't know. This is adapted from the new standards and it comes from